Hey everybody, thanks for coming out today. My name's Dylan and this is Katie, and we work for a consulting company called ZData. We have a lot of information packed in today into this 30-minute presentation, so we'll try to get through it all. So how many of you out there have heard of Spring XD? All right, Spring Cloud Dataflow? Almost everybody. So I think it kind of feels like at the beginning of the week when I was talking to people, not that many people really knew about Spring Cloud Dataflow. But as the week's gone on, I've heard more and more about it, just as I've been wandering through the conference. So today we're going to start by just giving a little bit of background about the two technologies, and then we're going to talk about a really common use case that we see over and over when we're working at ZData. So to start with a little bit of background about ZData. ZData is a big data consulting company. We were founded in 2012, and we have about 50 people spread all across the country. We typically work with software products from our partner technology portfolios. So we're a big pivotal partner. We work with all of their data products as well as Cloud Foundry. We also work with other partners like Hortonworks and IBM. We specialize in implementing these technologies in public clouds, such as Amazon, Azure, and even Google Cloud Platform. So when we come to a customer, we're typically helping them architect and implement a solution that's comprised of many different technologies, all running usually in a public cloud.
So we have an exciting agenda today for everybody. First, we're going to go over a common use case. We're building a data pipeline. Then we're going to be comparing Spring XD to Spring Cloud Dataflow. ZData has been using Spring XD since its inception, and we have extensive experience with this technology and some of its limitations. For the past few months, we've been working on the migration to Spring Cloud Dataflow, so we're going to give you some pros and cons and some helpful tips with this new technology. Then we're going to go through a hands-on example of building a data pipeline. We're going to be using technologies like Spring XD, machine learning models, Kafka, and some real-time web applications. And from there, we're going to have Kalen come up, and he's going to do a live code jam session for you guys on these technologies.
So over the past year or two, it seems like at ZData we've worked on projects that all share a common pattern. So over and over again, across verticals, across different industries, we see the same thing repeated. All these customers we're working with are dealing with streaming data that are coming from, might be telemetry data coming from connected trucks. It might just be transactional data being processed by web applications. But all of this data is streaming into the organization in real time. Once the data is in the organization, all of these customers we work with want to process that data in a pretty similar way. They'll want to transform that data, apply business rules to that data. They probably want to augment the data with data from another state store, pull it together, and then finally they want to cleanse it and get rid of bad rows, because in these real-time streaming use cases there's often bad rows, and we see a lot of bad data coming in that needs to be either cleaned up or simply thrown away. And then finally, customers want to apply more sophisticated machine learning algorithms to this data. They want to do things like prediction or classification, and they want to push the results out as quickly as possible to either web applications or mobile applications, or simply alerting systems to alert their customers of what's happening. So I'm sure you all probably saw in the news recently, ZData was awarded a grant by the state of Idaho to work with the Idaho National Lab on a connected farm initiative. And so in this use case, we're combining data from many different data sources. The most important one is coming from unmanned aerial drones that are flying over agriculture fields. They're capturing images of the crops and streaming those back to us in real time. We're combining that image data with many other sources, so sensors that are in the ground or telemetry data from the tractors actually working on the fields. After we combine all of this data together, we want to analyze it, classify it to do things like detect a crop that might be underwatered, or even find diseases that might be starting inside a certain crop. And then finally, we want to push that out to the farm owners as quickly as possible so they can take advantage of and fix that problem as soon as it's discovered.
So another example of a use case, ZData has been working with a company from Europe that has a large fleet of ships, and these ships are traveling from port to port all over the world. This company wanted to collect all the telemetry data from the ships, from the speed to the heading to the ballast, just all the components of the ships, and stream this in real time. So ZData helped them build a platform for this so that they could track where the ships were going to be, what ports they were coming to and from, which really helped with the business profitability for this company.
So we've repeated this use case many times, and I think probably all of you have seen something similar as well. We've done the same with online credit card fraud detection. Over and over again, we see a use case with this common paradigm. So when we get to a customer who wants to implement this pattern, we find that they really understand all the steps very well. They know all of the different components that need to be implemented. They know they have the data coming in, they know how to transform it, they know what they want to do with it, but the problem is they don't really know how to orchestrate this entire big data pipeline. So they might start by trying to code or develop something themselves. But that rarely gets them very far. As soon as they try to scale it, they run into a lot of common pitfalls. Scaling becomes a serious problem. If you detect a bottleneck in some of your transformations, scaling that out using your own framework is a really hard problem. Similarly, with high availability or failover, if you want these streams to be up 24/7, you have to put a lot of effort into designing and architecting these solutions. So that's really the reason that SpringXD was originally developed, to help orchestrate and handle these large data pipelines. But as we'll see in a minute, it had some shortcomings that caused Spring Cloud Dataflow to be developed as its replacement. So we'll walk you through that.
So to give you a quick history and overview of these technologies, SpringXD came about in about 2014. Right after it came out, ZData saw a lot of customers asking for the product, so we started implementing it. Its last release just was in February of this year, and it's currently in maintenance mode. Spring Cloud Dataflow also was released around 2015. Just became available for general availability in the beginning of July, so just a few weeks ago. In those past few weeks, we've been working on migrating all of our customers from SpringXD through to Spring Cloud Dataflow.
Yeah, so to kind of compare and contrast these a little bit, SpringXD shipped with its own runtime engine. So all of the orchestration was handled by the engine inside of SpringXD, which at the time was great, but that's also the reason that a lot of customers have struggled with it. Because that's just a very difficult problem to solve. There are tons of corner cases and things you have to think about. And so the main change between SpringXD and Spring Cloud Dataflow is that instead of using a built-in engine, Spring Cloud Dataflow is now running inside any modern application runtime of your choice. So it can run inside Cloud Foundry, it can run in Kubernetes, it can run in even Mesos and Yarn. And because of that, a lot of the problems that customers faced were alleviated. So for example, with SpringXD, you had to install and manage your own message bus. So you had to install something like RabbitMQ, and then you had to maintain that, which seems pretty simple, but what we found is that customers at scale had a real challenge with this. They had to teach their operations teams how to use that, how to maintain it, how to keep it highly available, and that often became a big bottleneck. When SpringXD jobs were failing, we'd oftentimes see it's because the message bus is actually down, SpringXD is working fine. That's alleviated in Spring Cloud Dataflow because now you can use the message broker service inside of Cloud Foundry. So Cloud Foundry will manage that process for you. We also commonly saw that customers had problems when they were troubleshooting their streams. So finding log messages was very hard because in SpringXD the logs are scattered across many different containers and instances. And so finding a problem was like finding a needle in a haystack. But of course now this is much simpler. Again, thanks to Cloud Foundry, all of the logs are centralized and you can use a command line tool like CF/CLI to easily pinpoint the problem that you're dealing with. We also found that scaling out was very difficult. So customers would design a stream, it would work great for their initial data set, but then over time their data volumes would grow and they would run into scaling problems. So scaling was certainly possible with Spring XD. You could try to scale out your transformation process, but it was a very manual process. You oftentimes had to add new containers or even add new servers to support the workload, and that became the operational problems were compounded at that point. As I'm sure you all know, Cloud Foundry can handle that much simpler. If you need to scale out a specific application, you can do that at the press of a button, or you can even use a service inside Cloud Foundry to make that process automatic. So this is what a finished architecture for us looks like now. So this is what we present to customers, and this is what we strive to help them implement. So they have data coming from any kind of a source. It's being streamed in to a message bus. It could be anything, but we use Kafka a lot. It's gaining a lot of popularity across the whole ecosystem. So we have data coming into Kafka, and then from that point on, pretty much everything else is running in Cloud Foundry. So the Dataflow server itself is an application running inside Cloud Foundry, and then every step in that pipeline is actually a data microservice running inside Cloud Foundry. So the transformations are a microservice, the PMML scoring engine is a microservice, and then the consumers, the applications, web, mobile applications are also running inside Cloud Foundry. Those could be Spring Boot apps, they could be any kind of an application. They can take advantage of all of the services inside Cloud Foundry, of course, but then they can also use service brokers to send the data out to a long-term storage platform. And this is important, especially when you get into machine learning. So at ZData, our data scientists work a lot with Spark and technologies like MLlib. And so they would be dealing with the bulk of the data in that environment. That's where they would be doing things like exploration, building the models, tuning the models, making sure that they're ready for production. And then eventually they would export those models as PMML, which is a portable format that stands for a predictive model markup language. And they would push that finished model back up into the scoring microservice inside Cloud Foundry. So you can start to really create a production workflow for your machine learning models that's very similar to the way that you handle your front-end application code. So one of the nice things about migrating between Spring XD and Spring Cloud Dataflow is that the command line interface stayed almost the same between them. So if you are used to using Spring XD, it's very simple to get used to Spring Cloud Dataflow, and so that's been very nice for our customers. This is just a quick screenshot of the CLI, but then there's also a graphical interface that's available as well. So this is that graphical interface. This is where you manage all of your apps, all of your streams. And so a stream is just composed of multiple apps all being pipelined together. Spring Cloud Dataflow ships with many applications out of the box that you need to get started. And then over time, you can develop your own applications to add into these streaming pipelines. They can be managed, deployed, undeployed from this interface.
So now we're actually looking at the command line. As you can see, there's 4 different sections for this. So we have the source, which is where your data is coming from, whether it's Twitter or JDBC, HTTP. Then we go to the processor. This is where your data is going to be processed. So whether you're using Splinter, Transform, or PMML, which we'll actually be doing a demonstration of in the demo today. And then to your sink, which is where the data goes. So if it's in Gemfire or FTP, that's where your data is going to go. And then finally, the task, which you can kind of think of as a job, which will have a beginning and an end. So a good example of that would be exporting the data from a database to an instance, which would be really a one-time deal. From there, as you can see, all of these are out-of-the-box skeleton applications, and they can all be customized. We can also create your own sync templates as well. And this new process in Spring Cloud Dataflow really makes it a lot easier to customize and use these different things.
So remember, when you're creating a stream, you're really just combining multiple applications together in a pipeline. And the way that you define these is through a DSL or a domain-specific language for Spring Cloud Dataflow. So this is what a very, very simple stream might look like. Look at the definition column there in the bottom. So we have an application called time that just prints out a timestamp. We have an application called log that would log that to a file. And then we combine them together using the pipe operator. So this is very similar to the way that you would string processes together in a Unix environment. But this DSL has some special properties that we'll see in a moment. But this stream would be deployed inside Cloud Foundry, be managed by Cloud Foundry. So either of these applications, either time or log, could be scaled independently. All of the failover would be handled for you, etc. So now going back to our example, this is our desired stream. This is what we want to happen. Remember that we want the data to go through this whole pipeline out to the end user. So to accomplish this, we really want to have two separate stream definitions. The first one follows the bottom path. So we use HTTP in this case to get the data, but that could be any application that's capable of getting data. Katie showed you a list of examples before. Then we run it through a transformation application. You can write a transformation application in any way that you want. A lot of times for simple transformations, we'll use Groovy. There's a Groovy transform application available. And then we would pipe that through the PMML application, which is our machine learning scoring engine. And then finally, at this stage of the pipeline, we would send it through the JDBC application, which is simply writing data out to that long-term data store. If we wanted it to go to Spark instead, maybe we'd use the HDFS application. The second stream down below is what's called a T. So we're going to pick up after the PMML step. So after the data has been scored, we're going to also, in parallel, send it to a WebSocket that our applications can read from to display this data as soon as it's available. So in a real scenario, each of these applications could take a whole bunch of command line arguments. We took those out just to kind of simplify it here, but we'll show you a real example in a minute.
So now we're going to have Keelan come up, and he is going to do a demo for us, our live code jam session on these technologies.
Hello, can you hear through this? All right, so I'm here to show you a quick demo, or as I like to call it, how many things can I run locally on my laptop until it lights on fire? Because we have a bunch of stuff going on locally right now. We're going to start out at the end, and then we're going to work our way backwards. We're going to see what's behind going on. Cross your fingers. All right, awesome. So I want to describe a little bit about this. This is not so important, this part of the demo. The data that we're seeing is in census data. We're taking features out of census data, and then we're predicting whether that subject is making above or below $50,000 a year. We're using Spark to do this, using a binary logistic regression machine learning algorithm. And we're just graphing a few results here. By the end of this demo, we want to see some kind of nice pattern with this so we know things are working. Let's start off with showing you a little bit about Spark, and then we're going to move into Dataflow. And then I'm going to kind of discuss some of the experience that I have working in a production environment with SpringXD, and what I think is promising about Dataflow, or what right now is better about Dataflow than what SpringXD had to offer. So Spark, we have just a single node version of Spark running on my laptop, which is dangerous with PCF Dev and Dataflow, because there's not much extra. I was afraid the PowerPoint presentation might actually overflow everything, but it seems to be working well. We're using Spark 2.0, which just had its a big release last week, just alongside Dataflow, actually. So we've got two pretty big releases that have happened pretty soon here. In Spark 2.0, we're using MLlib as our API to do this machine learning algorithm. We'll take a look at this code real quick. If I can make it bigger for you guys. So it's just a basic machine learning algorithm, kind of, I'd say, script written in Scala. We plug this in through the interactive shell. Most importantly, what we get out of this is a PMML, as Dylan was talking about earlier. PMML templates are very portable, meaning we train our model in Spark. We give it we export it as a PML, which is an XML template for it, and then we can use that template in many different scenarios. Right now, we can only export PMML models for a few different machine learning algorithms in Spark. In Spark 1.6.1, that's increasing by third-party extensions. Spark 2.0, there still needs to be work on that. So that's why we're doing a binary logistic algorithm. So we run this through the model, we export the PMML, we put that up into S3, and then we can access that from our Dataflow stream. We are using a local version of Cloud Foundry, a local development version, PCF Dev. Hats off to the guys that created that because it makes local development very, very easy. All of our streams, all of our modules, I guess our old terminology in Spring XD is modules, right, for the stream definitions. Our new terminology, everything is a Spring Boot app. They're much more development oriented. No matter how complex our stream was in Spring XD, we would still have a Spring XD layer, but above that, it still felt like we were always chaining together shell scripts and cron jobs to actually get things done, right? The data pipeline that you create in Dataflow is much more compact and developer oriented, I think. There's the days of having to undeploy your stream to update a module or update new features in Spring XD are gone. Okay, and that was a key thing. A lot of these streams that we used to develop for our clients, if there was any downtime, that was zero downtime is paramount for that. So if we can do rolling upgrades and if we can upgrade certain parts of our streams without undeploying a stream, then that's a win, right? So the biggest win for Dataflow for me is that category. Let me show you what the stream actually looks like that we're using to process that graph data. I don't know if this is going to be big enough. The very bottom here. So when you saw the example earlier of the time pipe log stream, those are the examples you're going to see. Time log, you're going to see HTTP log, these very simple stream definitions. You can chain them together to make them as complex as you want. And generally a production scale stream, you're not going to be able to read it, right, without parsing it out. It's going to be huge. Currently, what we have for this PMML evaluation is an HTTP endpoint. It just accepts JSON, right? The next one we have a Groovy transform. After that, we have the PMML evaluator, another transform, and then we sync it to our target, whether that's the WebSocket or JDBC, right? You will run into bugs, I've seen. You will run into bugs, especially when defining parameters on some of these Spring Boot modules that make up the stream. The Dataflow guys over at Pivotal are super responsive in fixing those, though. So post an issue, and they'll get right on top of it. But the release was pretty soon, and we have run into a few things. However, it's tend to work out pretty well. No longer, as Dylan mentioned earlier, do we have to worry about third-party services to help Spring XD. Two of those being Zookeeper and RabbitMQ. RabbitMQ service within Cloud Foundry is nice because you can scale up, scale down on service plans. Zookeeper is gone, which is very nice. We ran into some issues with that, especially. So once we talk to our stream, or once we can stream list. We're in the Dataflow shell now, which used to be the XD shell. It's exactly like the Spring XD shell, so there's not a whole lot of a learning curve there. But in your stream definition, everything between these pipes, which are actually queues in your RabbitMQ service or whatever message bus service you're using in the backend, those are going to be actually Spring Boot applications. Those will all list in your Cloud Foundry when you list your applications in Cloud Foundry. So it makes it very easy to customize those and then just push them up, right? That's all you have to do. You can upgrade tons of things about your streams. Our web demo application is, again, just another Spring Boot app. We can even scale up. So for example, if we're getting a ton of requests, and an example we've seen before where we have a Groovy transformation that is doing tons of mapping, If that bottlenecks, we can easily scale with this. And we can do it straight from the CLI. So let's do this. We've got one instance right now. We want two, and we're done. We've scaled it up, right? We can scale it back down. So it's very simple. In Spring XD, we would have to undeploy that entire stream. We'd have to edit the configuration properties. We'd cross our fingers and then deploy it again and hope everything worked, right? Many times it did not. So Dataflow is definitely on the right track. We can make this demo alone go for about 45 minutes and actually look through code, but we're very limited. So we're seeing a pattern with this demo, right? Younger people are making less money than older people, which is sort of how it goes in life. That's all the content I have. I'm going to pass it back to Dylan and Katie.
Yeah, just hold the question real quick. He'll be right back. So just to quickly finish up here, we'll address the elephant in the room that we were asked about. Katie, why is the squirrel on your shirt so fat?
Well, Dylan, squirrel is so fat because it's about ready to burst.
So Burst is a new service that was recently launched by ZData because we found that when customers wanted to get started with Spring Cloud Dataflow, it was very difficult. There's a lot of underlying infrastructure that you have to have to really test it out and to really start to scale things up. Mainly, you have to have something like a Cloud Foundry environment for that. And so we want to make that easy for you. So you can install your Cloud Foundry environment. You can use one of the versions from our AWS Marketplace offerings. And then you can connect them up with our product, which is called Burst. And from there, we can do automatic monitoring of that environment. We can keep it up and running, and we can provide managed services for it on an ongoing basis. Just about,
Burst,
yeah.
So you guys are probably bursting with excitement now after that awesome presentation and demo. Thanks for listening to us today. If you guys want to, we'll open it up for a couple questions if we have time, but we are hiring and, we're fun. We're bursting again with joy and excitement. So come chat with us after the talk or get in touch with us online or by phone.
Cool. All right, so you had a question?
Yeah, so you just mentioned about the deploying of streams. I had used Spring XD, so my problem was every time I introduce a new processor in between, I have to totally deploy the stream and destroy the stream and create it again. So how is the problem fixed in Spring Cloud or Dataflow or?
Yeah, you don't
What?
have to do that.
So the question was how do you deal with having to change a stream, having to undeploy it and then redeploy it again? Right.
So yeah, I feel your pain because I had to do that many times, especially when you're developing these streams. In Spring XD, we'd have to undeploy every single time. Hopefully Zookeeper kept up with everything to undeploy all these modules. If it didn't, if you had any kind of problem, you couldn't redeploy the streams, stuff like that. With the super nice thing about Dataflow, at least from what I've noticed with my brief experience with it so far, right, is once you kill a stream, all of those Spring Boot applications will die pretty much immediately. And that is pretty huge change because in the Spring XD world, what it would do is it would send, when you deploy a stream, it'd send a persistent definition over to Zookeeper, which would make sure those modules were deployed on the container servers. Sometimes when you undeployed those streams, it's like they weren't talking to each other. So they wouldn't actually undeploy, and so you try to redeploy, and it just wouldn't work. Dataflow solves that. So if we need to put a new processor in our stream, you define it. You can actually just push it up to Cloud Foundry, and everything else you can define either through the REST implementation of Dataflow server or the Dataflow shell CLI, the Dataflow shell, yeah. Oh, a way to kind of insert a new processor to an already run stream? It's a good question. I don't know. I haven't tried that. I'm so used to undeploying and redeploying streams that I don't know. I don't know is the frank answer with you. And I have to test it, but it'd definitely be something interesting to see in Dataflow.
Yep. So any other questions back here?
I don't know off the top of your head, but do you have any examples of some of the amounts of data that you've seen go through?
Sure. So the question is examples of the amounts of data that go through this pipeline. Matt, what's a good example?
I guess the best example with is, I have a lot of experience with Spark and Spark streaming in particular. And from what I've seen alone, the data flow stream and when evaluating predictions is much faster than some things in
What
Spark.
would the total volume be? Like messages per hour? Or?
Oh, I couldn't even put a number on it right now. A whole bunch, like a whole bunch. Sure, yeah, depending on your
Yeah.
Cloud Foundry installation, you could just scale it up to do whatever you need. It's going to cost some money, but you know.
Any other questions? Oh, sure.
So, in your stream, I know right now data flow, each and every activity is a Spring Boot application, right? And you can have metrics for each and every Spring Boot application.
Mhm.
Do you have stream level metrics to say, okay, you know, each and every activity took this much time between there's a pipe connected, right? It's going from Kafka and
Yep.
coming back to the next activity. So is there a stream for the whole,
Yeah.
metrics for the whole stream?
Yeah, so the question is about monitoring and metrics for an entire stream, not just a single application in the pipeline.
Yeah, definitely. That's what the Dataflow shell or the Dataflow server provides. So the Dataflow server in itself is a Spring Boot app, right? You can get metrics about all of your currently deployed streams through that. On top of that, you can get metrics about each one of your components of your stream or your modules, your Spring Boot apps individually too. One thing I do want to mention about that is in the world of Spring XD, when you would deploy a stream, you'd get three options: deployed, failed, or undeployed, right? With Dataflow, once you deploy a stream, the runtime takes care of those applications, and so it monitors them. If one goes down, your stream definition then turns to partial, which is just one extra flag, but it's huge. It's a very, very big addition into that.
Cool. So we're out of time, but we'd love to take any other questions out in the hallway if anybody has any. Thanks.